Let's discuss question number 35. What is the maximum mass of ice at -5 degrees Celsius that can be completely dissolved in 1 kilogram of water at 35 degrees Celsius in a container with negligible heat capacity? Right, let's see. So then I have 1 kilogram of water at 35 degrees Celsius. And then I have a certain amount of ice. So this ice should be converted to a water at 0 degrees Celsius. Right? Now listen, not all ice can be dissolved into water at 0 degrees Celsius. That's why they're asking for a maximum amount of ice. Right? So let's call the amount of ice that dissolves into water as mass m. Right? So what happens? Water at 35 degrees Celsius becomes what? Water at 0 degrees Celsius. And ice at -5 degrees Celsius eventually becomes water at 0 degrees Celsius. So in the process, ice heats up from -5 degrees Celsius into what? Ice at 0 degrees Celsius, and then the ice at 0 degrees Celsius becomes water at 0 degrees Celsius, undergoing a change in state. Now let's see this equation. So I can say mass of the water times specific heat capacity of the water times the temperature difference delta theta 1. What is this? This is the amount of heat supplied by water. Amount of heat supplied by this water. That should be equal to what? Amount of heat absorbed by ice at -5 degrees Celsius to become ice at 0 degrees Celsius. So for that, we have to have the mass of ice that dissolves, let's call it m, and specific heat capacity of ice is I times the temperature difference delta T2, plus mass of ice times specific latent heat of fusion of ice, L, ice, right? So what's the mass of water? 1 kilogram. Specific heat capacity 4000, so 4 times 10 to the power 3. Temperature difference, they're given the temperature difference, it's cooling from 35 degrees Celsius into 0 degrees Celsius. Therefore, temperature difference is 35. Right, is that clear? Then I can take a common factor, m is common. Then SI, what is SI? Specific heat capacity of ice, that's equal to what? They're given that 2 times 10 to the power 3. And it's in standard units, right? Temperature difference, yeah, ice is going to heat up from -5 degrees Celsius to 0 degrees Celsius. Therefore, the temperature difference is going to be 5 times 5 plus specific latent heat of fusion of ice. What's that going to be equal to? That's going to be equal to 3.4 times 10 to the power 5. But I'm going to write it like this. I'm going to write it like 340 times 10 to the power 3. Why am I doing that? Because I can see 10 to the power 3 here, 10 to the power 3 here. If it's wise to write 340 times 10 to the power 3 because the 10 to the power 3 can be cancelled off. Then I get 4 times 35 is equal to m times 2 times 5, 10, 10 plus 340, 350. Don't simplify early, like 4 times 35 early, it's a waste of time. Can you see 35 and 35 cancels off? Right? Then what can you see? You can see 0.4 kilograms is equal to m. That means m is equal to what? 400 grams. I hope you can understand this. Very simple question, right? Okay, so question number 36 is what we have next. Magnifying power of a compound microscope in normal adjustment is 100. The focal length of the objective lens is 2.5 centimeters and the object distance is 2.6 centimeters. What is the magnification of the eyepiece? What's the magnification of the eyepiece? Now let's see. Can you remember this? I have the objective here. I'm going to consider a compound microscope and we are going to consider the instant of what? Normal adjustment, right? So I have this objective lens, right? This is the focal length, f objective, right? Then if this is f0, this is going to be what? 2f0. I'm going to place the object between f0 and 2f0. Just remember the rough diagram. So then the ray comes like so, and then goes like so, comes parallelly and goes through this. So this is going to be f0 too, the theory, right? Now an image is formed, and this image is a real but inverted image, right? Can you see that? The image is what? Real but inverted, right? Is that clear? What's going to happen now? What's going to happen is this image is going to act as an object to the eyepiece, and the eyepiece lens is going to form a magnified image which is virtual. So that means if the eyepiece is going to produce a magnified image which is virtual, the image which is going to act as an object should be there before the focal length of the eyepiece, because it's going to produce an image which is magnified, and also the image that's produced is virtual. So let's see. So then I have to have the focal length of the eyepiece somewhere around here, Fe, and this is the image that's formed. It's going to act as an object, right? So I have the eyepiece lens. So I'm going to use imaginary lines like this to make it easier. So Fe is going to be somewhere around here. It's not exactly precise, but you can see the idea. So the image is formed somewhere around here, right? Image is formed. Okay, H dash. Can you see? Finally, a magnified image is produced of the object. Is the object, and then the magnified image is formed at the end. So there is magnification that's caused due to the objective lens, as well as a magnification caused due to the eyepiece lens. Therefore, we say magnification of the objective times magnification of the eyepiece is equal to total magnification of the compound microscope. The theory of this, you have to look at it like you have to go through the theory notes and refurbish these things. These ideas should be refurbished, right? Okay, but I'm giving you help. So once I teach this, you can go through the notes and then really thoroughly understand this lesson again, right? It's just a push for you, right? Now, they have mentioned the total magnification of the microscope as 100, right? But they ask for the magnification of the eyepiece, right? But we also don't know the magnification of the objective. But we have the data to know the magnification of the objective lens. Because we know the object distance. They have given the object distance. What's the object distance? This distance, object distance, they are given it to be what? They are given it to be 2.6 centimeters. And they have given the focal length of the objective to be 2.5 centimeters. So they have given us data, haven't they? So if we know the data, U and F0, we can find what? M0, right? Now listen, 1 over V minus 1 over U is equal to what? Or now if the lens equation. Applying the Cartesian convention, which means what? In the direction of passage of light rays, if we measure distances in the direction of passage of light rays, what's going to happen? It's going to be negative. But if I go in the opposite direction to the passage of light, it's going to be measured to be positive. So now can you see light rays are going like this, and from this optical axis I'm going towards the left, which means I'm going against the direction of light rays. I'm going against the direction of light rays. That means object distance should be what? Positive. So this is positive. But the image distance is going to be negative. Now this is the image distance, right? Because light rays are going like this, and I'm measuring the image distance like this. That means it's negative. And it's convention that the focal length of these convex lenses are negative. This differs in different books. Like if you take a foreign book, it's different. But in Australian syllabus, this is how you learn, right? So I can see eventually this negative, negative, negative here. I can multiply this by a negative sign. entire equation by negative sign, then I get 1 over v plus 1 over u is equal to 1 over f, right? Now look at this. I can do something like this because I want the magnification of the objective lens. The magnification of the objective lens is equal to what? Image distance divided by the object distance. So how can I get the image distance? Okay, then I'll substitute here and find the image distance, but it's easier if I can get magnification within this equation, right? So let's see that. What can I do? What I can do is this. I'm going to multiply this entire equation by u. What happens then? I get u over v plus what? U over u is equal to u over f. U over u is 1, u over v is 1 over magnification, because v over u means magnification. Then u over v means 1 over magnification of the objective. Plus 1 should be equal to u over f. Then I get 1 over m naught is equal to what? U over f minus 1. But what is u? Yeah, what's the object distance? 2.6. What's the focal length? 2.5 minus 1. I can write 1 as 2.5 over 2.5. You can understand why. Get the common thing. Then I get 0.1 over 2.5. That means 1 over 25. So 1 over 25 is equal to what? 1 over m naught. That means m naught is equal to what? 25. So I get m naught is equal to 25. M naught is equal to 25. M is equal to 100. 25 times what is 100? Therefore, m is equal to 4. Because 25 times 4 is equal to 100. I hope you can understand this, right? Yeah. Now let's come to the 37th question. Okay, 37th question. The charged particle in a circular path of radius r perpendicular to a uniform magnetic field penetrates through a thin aluminium sheet as shown in the figure. If half of the initial kinetic energy is lost due to penetration, what would be the radius of the new path of the particle? What would be the radius of the new path of the particle? Let's see. I hope you can remember the theory. I just give you some ideas of my own technique that I used to use. Right, let's consider a magnetic field like this. Right. Suppose we have a positive charge plus q moving like this with velocity v. Right. Just remember it like this. Hold your left hand and hold your palm like so. Ask magnetic field lines to cut through your palm. Feel it, right? Like you feel magnetic field lines are cutting through your palm. Right? Is that clear? Then they're going into the they're going into the whiteboard. If they're going into the whiteboard, that means they're cutting through our palm. But if it's coming out of the whiteboard, you should hold your palm in such a way that the magnetic field lines are cutting through your palm. You understand the technique? Now here in this case, well, magnetic field lines are cutting through my palm. I can feel it. The velocity is shown by these fingers, right? Fingers. So it's like a kind of movement, right? Is that clear? Kind of a movement. Therefore, velocity like this, magnetic field lines are cutting through my palm. Therefore, the force is up. Right? Is that clear? So the force is up. Now there's a force like this, magnetic force. Now this force F is equal to PQV in this case. But if there's an angle, it changes. So I should get, now if the velocity has a certain angle, then I should get the perpendicular velocity, right? Therefore the angle should be considered. We'll talk about those things later. But here it's perpendicular. Direction of velocity is perpendicular to magnetic field lines. If the velocity is in the direction of magnetic field lines, there is no force. Therefore you should get the value of cos theta or sin theta depending on the idea of velocity being perpendicular to magnetic field lines. For example, if the velocity v is like this and the magnetic field lines are like so, then I should take theta here. I should get v cos theta. So bq v cos theta, right? Yeah. So let's see. Here's bq v. V means magnetic field strength, right? Magnetic field intensity. Q means charge of the particle. V means velocity of the particle, right? Okay. Now, look at this. If you look at that, you can see that it can go along a circular path, right? What happens? But then the magnetic field should be there throughout, right? Magnetic field is there throughout. I draw a better diagram for you to see, right? So plus Q is here with velocity V, and these magnetic field lines are here like so. So the force F is like this, so it can go along a circular path like this with a certain radius. Radius is R. I'm reminding the entire theory, right? Is that clear? Now I can say something like this. What's the centripetal force equal to? BQV. There's no other force. BQV is going to provide the centripetal force for this circular motion. That should be equal to mv squared over r, centripetal force. You know it right there. V squared over r means centripetal acceleration. Then I can say radius of the path, because v cancels, is equal to mv over bq. Right? Linear momentum of this particle mv over bq. Right? Look at this. Further theories I'll be discussing later. Right? So you have this idea now. Now let's see the question then. What does the question mention? A charged particle moving in a circular path of radius r perpendicular to uniform magnetic field penetrates through a thin aluminum sheet as shown in the figure. If half of the initial kinetic energy is lost due to penetration, what would be the radius of the new path of the particle? So now initially it had the radius like this. But after penetrating the aluminum sheet, now before that it has this energy E, it had the energy E, now it has the energy E over 2. Because it loses half of the kinetic energy. But kinetic energy E means half mv squared. Kinetic energy E means half mv squared, right? Now tell me, how can kinetic energy be half if the velocity becomes v over root 2? V over root 2 squared means what? V squared over 2. Therefore, velocity has to become v over root 2 because v over root 2 squared is v squared over 2. Then kinetic energy becomes E over 2. So what has happened to the velocity? Velocity has become V over root 2. Now you know R is equal to what? mv over bq. M, B, and Q, they don't change for the particle. Mass, constant. Magnetic field strength, they have not changed. Charge, not changed. So R is proportional to V. Therefore, whatever happens to V should happen to R, the radius of the path. Therefore, radius of the path becomes R over root 2. I hope you can understand this.